So the focus for this lesson will be the alkanes. But what do we know about alkanes? Alkanes are basically the simplest of the hydrocarbon group. They are the simplest. Cool and chill. Taking life so easy. They are the simplest hydrocarbons out there. But why is that the case? The reason is simple. If you take a very close look at all alkanes, their carbon atoms or their compounds contain only carbon and hydrogen. And these carbon and hydrogen atoms have only single bonds between them. So the carbon-carbon bonds in all alkanes are only single covalent bonds. That makes them simple. And that's something so unique about alkanes. All alkanes have only single bond between their carbon atoms. And these alkane molecules are also known as saturated hydrocarbons. So, like I said earlier, we actually delve deeper into the classification of organic compounds in an earlier video under the foundation module. So you can check the link, or better still, visit the entire playlist so that you wouldn't miss any important points. Let's continue. So this example of an alkane you see on the board or on the screen is also known as what? A saturated hydrocarbon. Why is that the case? You see, in chemistry, the word saturated basically means that the carbon atoms out there have only single bonds and they are satisfied with hydrogen atoms. So pay a very close look at the hydrogens or the carbon atoms. If you pick one of the carbon atoms, you see that all around is only single bonds. Only single bond can be found. So the compound I have on the screen has 5 carbon atoms and all of them have only single bond bonded to other atoms. So that's what makes it or makes them saturated hydrocarbons. So let's look at some examples. If you take a very close look at all the examples you have on the screen, the straight chain, the one that forms a ring, then the branch one, all of these have only single bonds. Take a very close look at it. All the carbon atoms have only single bond. There is no double bond present anywhere. So for saturated hydrocarbons, specifically in alkanes, you see that there is no carbon-carbon double bond. So pay a second close look at the compounds. No double bond present anywhere. Now, there's a unique example we have on the screen, that is the one that forms a ring. So all alkanes that form rings are known as cycloalkanes, like cycle. So the carbon atoms go back to loop on each other. So these are examples of cycloalkanes. Now let's press the gear and move to much more complex issues under alkanes. So alkanes have a special code in the form of mathematical expressions that helps us to tell the number of hydrogen atoms that are needed depending on the number of carbons. So this special code is the CnH2n plus 2. This special code is known as the general formula of alkanes. So if you ask to state the general formula of alkanes, you would say CnH2n plus 2. This is what it means. So let's pick an example. So suppose the number of carbons are 2. So suppose you have been given this clue that imagine an alkane with 2 carbons. How many hydrogen atoms should bond with these 2 carbons to form a correct alkane? The formula you are going to use will be CnH2n plus 2. What that means is that if the carbon atoms are 2, then the number of hydrogen atoms needed to bond with these 2 carbons will be 2 times the number of carbons plus 2. The number of carbons is highlighted in red. So let's pick an example. So we have carbon being 2. So we have 2 carbons. What about the number of hydrogens that should bond with this carbon? It will be 2 times the number of carbons plus 2. So that will give us C2, that the H will be 2 times 2 is 4. 4 plus 2 is 6. So the formula for this alkane will be C2H6. I think that's simple and straightforward. Good. This kind of formula, that is C2H6, is known as the molecular formula. So if you see this, that is a molecular formula. We will define what's molecular formula in a jiffy. Now, this C2H6 can be written in a different way, which is known as the displayed formula. It will also be explained. And this can also be written as CH3CH3. So let's pick them one after the other and see. So our first focus is the molecular formula. So what exactly is molecular formula? I'll read and then explain. A molecular formula shows the actual number of atoms of each element present in a molecule, but does not show how atoms are bonded or arranged. So the key point we have to take from the molecular formula is this. It shows the actual number of atoms of each element present. So if you see C2H6, the molecular formula just tells us that there are 2 carbons and 6 hydrogens. That is all what molecular formula does, without giving you any detail as to how the atoms are bonded or arranged. That is molecular formula. What about the displayed formula? The displayed formula actually goes ahead to show us how the various atoms are bonded and shows all the bonds in the molecules as individual lines. That is what displayed formula does. So if you look at C2H6, it doesn't just tell us the number of carbon present and the number of hydrogen present. What it does is it shows us how the carbons are spaced out. So you see carbon and another carbon. And the first carbon, the lines represent the bonds between the first carbon and the 3 hydrogens. Then the second carbon and the 3 hydrogens. This is what displayed formula does. What about structural formula? For the structural formula, which is also CH3CH3, shows the arrangement of atoms in the molecule in a simplified form, also showing which atoms are bonded to which. That is one interesting thing about the structural formula. It tells us that carbon 1 is bonded to 3 hydrogens and carbon 2 is also bonded to 3 hydrogens. That's what the structural formula does. But if you look at the molecular formula, it only tells us C2H6. That's all. But structural formula tells us how the atoms, which atom is bonded to which. So I think that's quite interesting. So these are the various ways to represent an alkane molecule. So here's a quiz for you. Determine the molecular formula of an alkane with 8 carbon atoms, and then how many hydrogen atoms are present. So here is the answer. We first have to know the general formula. The general formula we already discussed is CnH2n plus 2, where N stands for the number of carbon atoms present. And in our question, the number of carbon atoms present is 8. We have 8 carbon atoms. So if you put that into the formula, we have C8. Well, what about H? We have H2 into brackets 8 plus 2. So that gives us C8H18. Because if you check the hydrogens, we have 2 times 8, that is 16. 16 plus 2 is 18. So that means we have 8 carbons bonded to 18 hydrogens. So our second part of the question is how many hydrogen atoms are present? That is, there are 18 hydrogen atoms present. I think this is easy peasy, right? It should be a work in the park. So you can practice with more examples out there for you. Now our next question is to change the following displayed formulas into structural formulas. Displayed formulas to structural formulas. So all the formulas you see on the board are known as displayed formulas. How do we change it into structural formulas? Remember what structural formula does? It tells us which atom an atom is bonded to. So if you pick carbon, the first carbon atom, it tells us which hydrogen atoms is bonded to and how many of them is bonded to. That is what this structural formula does. So let's look at the first one. How many carbons do you see out there? I think there are 7 of them. Yes, so you can count to verify. There are 7 carbons out there. So to write the structural formula, you have to take them carbon by carbon. So let's pick the first carbon. How many hydrogens do you see attached to the first carbon? There are 3 hydrogens. I think you also see the same thing, right? What about the second carbon? How many hydrogens attached to the second carbon? Is it 3? No way, that's 2. So far we've gotten CH3CH2. And about the third carbon? How many hydrogens? Still 2. The same thing, still 2. Move to the next one, still 2. The next, still 2. What about the last carbon? We have 3 hydrogens attached. So the formula at the top is the displayed formula, and now at the down is the structural formula. What about the next example? So you can pause the video and try this and then compare it to the answer we have. First carbon is having 3 hydrogens attached. The second has 2. The third has 2. Fourth has how many? It has 2. I think you got it right, right? Okay, then the last one has 3 carbons. Or 3 hydrogens, right? What about last example? Is this looking tricky? If you are so sure of yourself or you know what it is, then you can pause the video and write it out in the comment section. Okay, for those of you who have paused and come back, here's how it is done. The first carbon has 3 hydrogens. The second has 2. What about the third? It also has 2. What about the fourth carbon? It also has 2 hydrogens. What about the fifth carbon? It also has 3. So you will say, oh, this formula is the same as the second one. Yes, it is. And the displayed formula for the third compound is the same as what you see in the second one. So this, I just bent it, but it's actually the same thing. So do not let this trick you. Okay. So this brings us to the end of our first lesson on alkanes. And we are still on alkanes for our next lesson. So for our next lesson, we'll be looking at how to name alkanes. But I'll focus on straight chain alkanes. So what should you expect in that lesson? Well, we'll look at how chemists come up with the naming of alkanes or organic compounds. And we'll look at the rules involved in naming organic compounds in general and apply that to straight chain. And if you understand that, we'll carry that on to all other organic compounds. See you in our next lesson.